So welcome and thank you for your interest in this presentation. My name is Christine Devine and I'm a STEM educator with the Student Success Group at QUT. And today I'll be joined by my colleagues Josh Riley and Dana Burfield, also STEM educators with SSG. And we'd like to take this opportunity to tell you about how we have adapted our science skills training program, that is Kitchen Lab, which operates primarily in the co-curricular space to meet the needs of learners at QUT during a pandemic. As scientists and educators, we recognise the value of lab-based learning experiences for developing confident and skilled STEM graduates. The hands-on lab work builds technical proficiencies in laboratory skills and supports deeper learning of the content. However, we also recognise the challenges of working in this space and know that this ideal situation can be difficult to realise for students. Undergraduate laboratory time is often brief and assessment driven, and of course, laboratory time is notoriously expensive. Crowded curriculum means that students are more focused on the outcome, that is the assessment, rather than the process. And we know for our students at QUT, this is often a new environment for many students, meaning there are often assumptions about the knowledge and skills that they bring. Another aspect is that laboratory practicals, given these constraints, are often predetermined in their outcomes, and students are typically not allowed to explore outside of the context of the activity. There may not be time to work out or explore why an activity did not work as planned, since the emphasis is going to be on what is necessary to complete the assessment, meaning that there are limited opportunities to master skills or recover from failure. We were motivated to develop the Kitchen Lab program to support our science undergraduates, who are of course a diverse group of learners, to get the most out of their lab time. The program was developed in partnership with stakeholders, that is faculty academics, laboratory technicians, sessional academics and support staff, so that it met the needs of our learners. The program importantly aligns with but sits outside of the curriculum, and this is critical in demonstrating value to participation for students. The program is a way that we can scaffold learning and skill development, and critical to that is that we make it a safe place to fail. Because there's no assessment associated with Kitchen Lab, if something doesn't work, it doesn't matter. In fact, that's great because that's an opportunity to learn. And we try and make them quite lighthearted, engaging and accessible so that there are no barriers to participation for students. So in terms of what this actually looks like, we deliver these hands-on, face-to-face workshops on campus. So you can see some pictures here from titration, spectrophotometry and experimental design. We ensure that the workshops are collaborative, that all the students have an opportunity to get their hands on the equipment and that they are actually working through the process in these experiments. Not surprisingly, we were quite encouraged by the success of the program in 2019 and we're looking forward to a productive and successful 2020. But of course, then COVID happened. So a rapid transition to online learning for everybody, staff and students. For those of us in the sciences, it meant the absence of hands-on laboratory-based activities. And instead, we were looking for ways to support that learning and those skills in our students. At the same time, of course, it's important to recognise that it was a stressful time. Students often reported low motivation and they were reluctant to engage with one more thing. We were essentially in survival mode. And so for a program like Kitchen Lab, which is pitched in the co-curricular space and that does not have assessment associated with it, what then is the value proposition for students? So in order to adapt in this time, in the week when COVID actually forced us to move online, we were gearing up to do a very large embedded workshop around scientific inquiry for pre-service education students. And so what we quickly did was move that into an Articulate Rise module so that students could do that, work through that at home as opposed to in the classroom. But of course, What we realized from this is that when you are in lockdown, you may not have the same accessibility to reagents and materials as you did when you were on campus. So there are still some potential barriers to engagement for our students.
So we were all forced into this period of rapid change, and we wanted to see how everybody responded to this rapid change. So we decided to do a global survey, and we're going to present some preliminary results from that survey. We had 35 responses, and they were dominated by Australia, New Zealand, and North America. Most of them were from universities, though there were some technical colleges and community colleges in North America. Most of the people that responded were lecturers or professors, and most were in the field of biology. We asked how people adapted their teaching, and I'm going to split that into two major categories. One, they went and completely online, and two, they maintained face-to-face hands-on learning. However, they adapted the way that that learning was delivered. Now you'll notice these don't all add up to 35 because sometimes people did more than one adaptation of their teaching. Most people provided some sort of videos of their labs and practical activities, sometimes associated with a data set. Several removed all of their lab and practical activities, and others provided additional resources to support remote learning. Those that were able to maintain face-to-face teaching changed the staffing ratio so they could have appropriate physical distancing, or they modularized the delivery into an intensive mode delivery. Now, the other category is actually what I find the most interesting. And there were two instances where people were able to provide at-home hands-on learning. And that's something that we're incredibly interested in at QUT, and we're going to talk in a great deal more detail about later in this presentation. When we went and looked at the narrative comments from everybody in the survey, we found there were two categories. There were challenges and opportunities. So one of the big challenges was this rapid change, that 1 week everything was, quote, normal, and then the next week we were being told everything has to go online for the rest of the semester. But there's also some uncertainty. Is it the rest of the semester? Is it a couple of weeks? Is it next semester? Is it next year? We don't really know. People also said there were challenges with student engagement and that they felt like a lot of their teaching was one-sided, and that they were kind of talking into the black box of the computer and not necessarily hearing back. The other concern that we have is this lack of hands-on skill. And if you looked at the previous graph, there were a lot of the groups, a lot of the responses where over half of them completely removed any sort of hands-on skill. So what does that mean going forward? You know, we have students who have a 3 or 4 year degree and they're missing a semester to a whole year of those practical skills. And when they go into the higher level units, what does that mean when they don't have those prerequisite skills? The other thing people noted was that there's a challenge with assessment and how to deliver assessment online. On the opportunity side, people noted that they had developed new skills in online teaching, and they think that actually some of the student learning and engagement may have been improved because the students, instead of being in groups of 4 in a practical class, were learning remotely and therefore had to learn everything on their own. There was also flexibility and accessibility for students that may not exist in a face-to-face environment. And they were able to redesign courses that they maybe had always wanted to redesign and never had the chance to do, and ultimately were forced into it.
So from what we see around the world with our data, there's lots of labs that have had to quickly make the shift to online environments, and that's led to a lot of asynchronous learning and a lot of students perhaps not getting as much time on the tools as they used to, and maybe not as much individualized support. For us, this was a big challenge, given that Kitchen Lab is all about that individualized support. It's about getting our students' hands dirty and on the tools so that they're better prepared to be in the lab. So we therefore decided that we couldn't really take the lab away from our students in this new scenario, and that instead, if they couldn't come to the lab, we needed to bring the lab to them. And so we designed some take-home kits for these students. So as you can see in these images here, these kits are a pretty light but sort of big box that students can pick up on campus, and inside them are enough reagents and equipment to perform multiple different experiments for them. And the advantage of these kits being developed by us is that they're not based on generic experiments, but rather what we've done is utilize our relationship with unit coordinators in key units within first year, for example, so that these experiments are aligned to what the students need to be doing in their coursework. To give you an example, one particular first year chemistry unit in our course has a rather large titration practical report that's due in the middle of semester. And so as part of this kit, we provide all the tools that students need to perform their own acid-base titration in their own home using just simply bicarb and citric acid. So as you can see from this quote here, the students were really excited about it. They think it's an awesome initiative. However, we also recognized that it can be a little bit daunting for students to just be given all of this stuff and left to their own devices. So while we wanted to keep it flexible, we also put in place a lot of different steps to make sure that students had the support and the scaffolding that they would need. So this essentially looks like one giant centralized Padlet that we designed for Kitchen Lab take-home kits. And as you can see from the image, there's everything the students would need to look up while they have these kits at home. So there's MSDS sheets for any chemicals that we've put into the kits, although everything's low risk anyway. We've also photographed every individual component of the kit and provided an explanation of what that piece of equipment or reagent is. So you can see in the image here that there's a picture of pH paper, and we've described what it's doing, how much they've received, and what they can use it for in their experiments. And the other thing this Padlet is going to be used for is for students to be able to share their own experiments. So we're hoping that as this goes on, this Padlet will also populate with students posting their own images and their own reflections of how they went at home with these experiments. And lastly, the idea of the Padlet is to connect to the other resources that we're providing for these take-home kits. So the main way that students will be performing these experiments is through using Articulate RISE modules that are designed to guide them through the steps of the experiment and how to analyze their data. And then the other thing that's linked here are registrations for Zoom sessions with members of the Kitchen Lab team. So the idea is that these sessions are very flexible and they're not tied to a particular experiment. We want to meet students where they're at so they can try any experiment anytime they like, and then come along to one of these sessions either before or after or during an experiment, and we can help them out and they can interact with other students who are also using these kits. So what I'll do now is just quickly show you a little peek of one of our Articulate RISE modules that complement the experiments our students are doing. So you can see here, this is just a little snippet of our Exploding Marshmallows experiment module that students can work through. So the idea with these modules is we want them to be able to have as much room for mastery learning and fact checking and multimodality, given that these are done asynchronously and students aren't able to get that immediate confirmation from another instructor. So as you'll see throughout, there's lots of different areas where students are able to interact with the module and check their understanding. So for example, here's some hypotheses that are given, and they need to try and work out the dependent and independent variables, and they can check their answers. So the idea with this module is that we've integrated in a lot of different media. So there's photos, there's files that can be downloaded, there is video, there's example calculations on things, and it moves through like this. So hopefully with these sessions, students will be able to work through the experiments while being guided in a flexible manner.
And with that, I'd like to thank you for stopping by to view this presentation.